Good. Hello, everybody. It's Malcolm Yulkin.
Hello.
Shall we start, or we have to wait for a while? Any suggestions? Any ideas?
I guess if we have the first speaker, we can start.
We can. Okay, cool, good. So we're going to talk a little bit today about climate change mitigation and adaptation. I have two of my colleagues accompanying me for this session, particularly Vladimir Sidorovich and Alexander Chernokulsky. I would probably suggest that we start with a small presentation about what climate change is all about and how we can adapt to climate risks. So then we will continue with a presentation by Vladimir Sidorovich about the key trends in global energy sector development, which will cover the decarbonization and switch to renewables. And then we will proceed with the presentations by students. So the idea would be also to kind of assess or evaluate the presentations and select the best speakers from the student side. And then we will decide how we will celebrate this victory. All right. So I will give the floor to Alexander Chernokulsky. Alexander, the floor is yours.
Mikhail, thank you. So yes, good afternoon, everybody. I want to share my screen. So I hope you see it. Is it full screen?
Now it is.
Yes, okay. So yes, I want to talk today about key issues of climate change risks and adaptation, and just to highlight some slides on the climate change at all as a first speaker, but probably you know about it. When we talk about climate change, first thing that came to mind is the global warming, is the increase of temperature, global temperature. So here is this picture for global temperature, global surface air temperature. This is from the end of 19th century to the 2021. 2021 year, and compared to the mean for the 20th century, and you see that we have increase of temperature, and probably from the end of the 19th century, we have already 1 degree warming, 1.1 degree warming. So we already have a lot from this Paris Agreement, 1.5 degree. That we have to stop to limit the warming. So we already have 1.1 degree. And this is global warming. If we go to some regional aspects, we see that, for instance, for the northern hemisphere, for Russia, for Arctic Russian regions, we have trends that 2 times and 3 times more than global trends. So the warming is not uniform. It depends on region, depends on surface, is it of ocean or over land. It depends on latitude, and actually it depends on seasons. We have more warming in winter, and it depends on the day, on the time of day. The warming is more intense at night, for instance, than at day, and so on. So a lot of some aspects of warming. Of course, not only temperature change, we have a lot of changes in other climate components, climate system components. We have, for instance, a decrease of mass volume of glaciers over land, and glaciers in the Greenland and in the Antarctica. We have increase of permafrost temperature, we have increase on sea level, and so on and so on. So actually a lot of changes in all components of climate system, in biosphere, in lithosphere, in hydrosphere, and in cryosphere, apart from atmosphere, of course. Atmosphere, was the first where we see changes, it was atmosphere. But we also have increase of number of extreme events that have some economic loss, that leads to some economic loss. We have not that big changes in geophysical events like earthquake or tsunami or volcano activity, but we have a big increase in meteorological events and hydrological events, kind of flood, storms, tornadoes, and so on, and also increase in larger scale events, kind of heat waves, droughts, and so on. So almost from 300 to 900, this is number of events. But of course, here's not only climate, here's also our exposure to these events. They both sit here in this trend. And scientists actually very sure about the causes of current climate change. So actually we have a lot of causes of climate variability, this kind of natural causes and external and internal, kind of astronomical, geological, solar activity, and so on. And also we have this anthropogenic forcing. And when we talk about current climate change, the climate change that we experience right now, the main reason, the main cause for this climate change is anthropogenic forcing. Actually, there is several lines of evidence about this forcing. So first of all, we have carbon balance in atmosphere. About this CO2 concentration, for instance, in atmosphere, it's unprecedented increase. At least for the last 1 million years. Here's some this reconstruction of CO2 concentration based on ice cores from Antarctica and combine it with the observation for now, and observation for last 70 years. This is the vertical line here. So actually CO2 concentration was never so high previously, so at least for 1 million years. It was that high or even more higher, but like 70 million years ago, 30 million years ago, but the climate was completely different.
Игорь, включите, пожалуйста, микрофон. Настя.
Я в теке, знаешь, там где-нибудь вот есть, знаешь, типа такой случайный, типа
Настя.
Could you please switch off the microphone?
Yeah, okay, thanks.
Yes, okay. So the second evidence is the isotope content of CO2 in the atmosphere. It changes a lot. We have a decrease of carbon-13 in the atmospheric CO2. So we have a new sources of CO2 that have lower content of carbon-13, and fossil fuel is that source. It contains less carbon-13 compared to other components of climate system. We have direct measurements of radiative fluxes. We have increase of this downward long-wave radiation that came from the atmosphere because of the intensification of greenhouse effect. We have a response of air temperature at different levels that this response is exactly a response to intensifying of greenhouse effect. We have increase of temperature in the troposphere. This is kind of ice. This is hockey stick. We have small decrease of temperature in the 15th to 18th century, and then big increase in temperature from the end of 19th century. But we have a decrease in temperature in the upper atmosphere, in the mesosphere. This is about 80 or 90 kilometer height altitude, and we have a decrease of temperature here. This is because of this intensification of greenhouse effect. We have more more heat that's stored in the lower level of layer of atmosphere, and less heat comes to the upper layer of atmosphere. If, for instance, we have increase in solar activity, both warming, we have both warming in troposphere and in stratosphere and mesosphere. So, but if we have intensification of greenhouse effect, we have warming in troposphere and cooling in mesosphere and stratosphere, and we see it from the observation. And of course, the very important evidence is the infeasibility of climate, inability of climate models to reproduce current global climate changes if they lack anthropogenic forcing. For instance, if they take into account only natural causes, models cannot reproduce this increase of temperature. But if they take into account aerosols and greenhouse gas emission and land use changes, they more or less reproduce these changes. Of course, not the interannual variability, but the trend. The trend can be reproduced if models take into account all forcings, not only natural forcings, but natural and anthropogenic. So it's kind of solid evidences that current climate change attributed to anthropogenic influence. And so if we have these models, if we have this understanding of causes, we can make a projection. So for instance, if we have some information about how society will change, how the population, education, urbanization, industry will change, we can calculate how greenhouse gas emissions and aerosol emissions will change, and understand how radiative forcing will change. So, and because of that, we can project climate. We can make a projection for temperature, for precipitation, for weather regimes, and so on. And actually, there is more or less linear relationship between cumulative CO2 emissions and global warming. For instance, these five scenarios that a lot of climate models make a calculation with these 5 scenarios. And these 2 first scenarios, they're kind of Paris Agreement scenarios. This is a scenario with 1.5 degree warming, and this scenario is with 2 degree warming. And actually, we have just about 500 gigatons CO2 left to emit to achieve this goal. So this is as I remember, this is a CO2 equivalent. So it's kind of 10 or 12 years that we left to achieve this warming with 1.5 degree. But probably about this, Vladimir will talk more. So when we have climate change in some place, we have risks of climate change that are associated with these changes. We have both risks. We have physical risks and we have transitional risks. When we talk about transitional risks, it's risks of changes of our economy, of our energy sector, and so on, and some regulatory changes. But when we talk about physical risks, this is risk of climate change itself. It divided into acute risks, so it's kind of risks associated with the extreme events, and chronic risks, that risks associated with climate regime changes. It's kind of long-term changes of temperature or precipitation or sea level, and so on. So, and when we talk about climate risk, we can divide it into 3 major components about hazard. This kind of increase in the frequency of severe weather events or exceeding the threshold values, and so on. So it's kind of side of the climate. We have exposure. This is our how we are exposed to this hazard, to this climate change impact. For instance, we are located in this region and we expose this climate change. For instance, these severe weather events. And also its vulnerability, it's our sensitivity, objects of people to this climate change impact, to this particular event. Are we sensible to it or not? So it's kind of vulnerable to it or not. For instance, and when we talk about risks, we do not talk about risks of flooding. We talk about risk of housing loss, for instance, because of flooding. And here's examples about these 3 components when we talk about flooding. For instance, the hazard here, this is a climate change impact that resulted in changes, for instance, in maximum water levels in this river. How frequent we will have this maximum level, and will it increase or not? So it's only about the level in this river, the level of water in this river, and how frequent we will have this flooding on the river. Exposure, for instance, this can be locating buildings on a floodplain. So if you build your house on a floodplain, you have to understand that sometimes the water comes to your house because this is a floodplain. But is it come to you 10 times per 100 year, or 8 times, or 20 times? That depends on some climate side. But if you build your house in a floodplain, just be aware. And vulnerability is kind of the type of your house. For instance, your house can be like that and stood on some I forget the words. Okay, so it can be like that, or it can be like that, and you are different. Your sensitivity is different to this, to the flooding, to this increase in the river water level. And what can we do to minimize these risks? So we can do both. We can mitigate. So we can reduce our anthropogenic forcing. We can reduce our carbon footprint. And because of that, we will have less warming than with high carbon footprint, and we kind of minimize risks of climate change in the long-term perspective. And we can also adapt. So adaptation is mostly reducing exposure and vulnerability, but we minimize risks of climate change in the short-term perspective. We do not think about. So when we talk about adaptation, we do not think about a level of warming, expected level of warming. We just think about our impact right now. Oh, maybe in some future, but anyway, we talk about impact. But when we talk about mitigation, adaptation is impact of climate to us, but mitigation is our impact on climate. So it's kind of two opposite direction. When we talk about adaptation challenges, we have some case stages. For instance, we can identify all possible risks in some places. We can identify trends for hazards. We can find thresholds and establish metrics, for instance, for hazard, for vulnerability, for exposure. And after that, after finding these thresholds, identifying all possible risks, we can lower exposure and vulnerability. And for instance, we can make stronger resilience, for instance, but also we can try to lower hazards. It's possible in some places. And also very important stage for adaptation is to compare effectiveness of various options for adaptation, because it's, of course, there are some options, not only one option. There are some tasks for different areas. There are scientific, social, technological tasks, and institutional tasks. So, for instance, we can improve our observation. We can improve our information and education for society. Of course, a lot of technological tasks, for like kind of technology for the protection of roads and so on and so on. For instance, here I put one example of effective adaptation for a city. In 2003, there was a very severe heat wave in Europe that resulted in 30,000 premature deaths, mostly in large cities and mostly in France. But why in large cities? Because there is an urban heat island that intensified this heat wave. And after that, European people realized that climate change is real. And actually, they start to ask their government to do something with climate change. But also, there is a lot of adaptation measure that was implemented after that. And for instance, in 2019, in 2020, there were more extreme severe events, but not that much premature deaths. That it's all because of adaptation measures that have been taken. For instance, it was a greening of streets and houses. If you put a lot of green trees or bushes and so on, you can lower the temperature because some energy goes to evapotranspiration. And this is the same if you add water objects. For instance, it could be fontaines or wet pavements, and it's implemented in some cities. And also a lot of cool pavilions created in some cities, for instance, in Moscow, in Vienna, where elderly people can be safe at day. They can rest there. And also it's informing of people. It's special application to the smartphone for smartphones. So what can you do, what you have not to do, how many water should you drink, so and so on and so on. So actually this is a big complex stuff, how to adapt to these heat waves in a large city. And actually the question can arise: adaptation or mitigation. If you have some money, you can spend it to adaptation or to mitigation. And if you mitigate, you reduce higher but delayed risk. And if you adapt, you reduce lower but already existing risks. And actually a lot of works shows that it is more efficient to do both of them. Adaptation and mitigation, you can reduce your total costs for climate change damage, minimize by adapt to them and by mitigate the climate change itself. And actually right now some interesting measures taken that combine both adaptation and mitigations. For instance, you can adapt your forests and to reduce vulnerability of forests to fires and to like droughts, but also this reducing of vulnerability of forests reduce also carbon footprint, so less carbon goes to the atmosphere. And actually some techniques are implemented into agriculture, into urban planning and so on. I think that's kind of this synergy between adaptation and mitigation is kind of that we need in future. I think that's it. If you have some questions, I will be glad to answer to them.
Okay, cool, good. I guess well, if there is one or two questions just to clarify, then you are welcome. Are any? No.
Okay.
So then we move on. Vladimir, now it's your turn. So what are we expecting in the key trends for the world energy sector development in the coming future?
Well, hello, everybody. По-английски, да, нужно, Mikhail?
Yes, please.
Let me speak from my heart in English. Sorry for my Russian
Can you do it like a full screen?
Sorry
please?
from my Russian presentation. I didn't know that we should talk in English. Well, a couple of words about the main trends of the world energy, about the decarbonization and renewable energy sources. Well, as you probably know, one of the main processes in the modern economy is called the energy transition, or like Germans say, Energiewende. Well, main features of the in energy transition are outstripping growth of renewable energy sources, renewable energy, and other so-called new energy technologies. I would say the second feature is 3D, means decarbonization, digitalization, and decentralization. Then we can talk about changes in the fuel structure of the world economy. Very important feature is the electrification of the energy consumption, of the final energy consumption in the world. Then we can talk that the climate policy will become an important technological factor. It means it will be difficult to it will be difficult for you to produce something without looking at your carbon footprint, looking at your greenhouse gas emissions. Well, as you probably know, almost all countries of the world are committed to carbon neutrality, to most countries to 2050. Some countries like China, Russian Federation, Saudi Arabia to 2060. A few countries like India, for example, to 2070. What does climate or carbon neutrality means? It means zero balance of greenhouse gas emissions or net zero emissions. We can reach carbon neutrality by reducing emissions and by compensation of residual emissions. We have in October 2021 is BTI science-based initiative
to show the slide, so it's the same slide all over the world.
Sorry?
It's the same slide. Can you move on with the slides somehow?
Что, я двигаю слайды.
No.
I guess there is a problem with the slideshow again. It sometimes happens in.
Can you
PowerPoint.
start not do can you relaunch it once again? Because we only see the slide with the climate pledges of countries. That's all.
Ну а что делать?
Попробуйте нажать на слайд-шоу, и там будет, по-моему, в левом окошечке там будет тоже начать презентацию.
Сейчас видно?
Но все равно он не полноразмерный. Он вот какой-то кусочек только показывает. Anyway, ладно.
Вы попробуйте на F5 нажать.
F5?
Да.
Ну, то есть у меня запущена демонстрация экрана, у меня все листается. Я, честно говоря...
Ну, у нас...
Это с PowerPoint такая сейчас часто проблема. Может, когда просто вы будете листать...
Вы тогда можете просто слайды переключать, да.
Так я переключаю слайды стрелками, да?
А он не переключается.
Вот, сейчас переключился слайд.
О, сейчас появился следующий слайд. Сейчас появился первый слайд. Нажимаем еще второй. Дальше.
Вот сейчас
третий.
все двигается, да.
Да. Теперь, если можно, еще полноразмерный экран сделать.
Полноразмерный?
Да. Не получается. Ну, не получается.
У меня получается.
У вас-то да, у нас нет. Ладно, пусть будет не полноразмерный, только он двигался. Да, вот так и живем, да. Поехали. Sorry. Let's continue.
Well, a couple of words about the new standard of SBTI, Science-Based Target Initiative, about this net zero standards. According to this new standard, all companies have to reduce the emissions according to 1.5 trajectory and well, ну, вы мне, честно говоря, признаться сложно, я потому что не готовился по-английски. Мне сейчас так переключиться на английский неожиданно, достаточно сложно, как бы.
Ничего, it's all right. Sounds good.
Some people ask me, show me the energy transition. It's quite simple. Let's take a look to the power generation in Germany on the left and Great Britain on the right. as you can see, we see the outstripping growth of the renewable generation and the decline of the power generation using fossil fuels. Let's take a look to the net capacity additions in the world power sector. As you can see, seven last years in the world, adds more renewable energy capacity than fossil fuel power capacity. Therefore, we have quite rapid changes in the power sector structure. And fastest growing sectors of the world energy are solar PV and wind power generation. They grow really very quickly and faster than other much faster than other sectors of the other energy sectors. And if we take, for example, World Energy Outlook by International Energy Agency, we see following projections, following scenarios of the development of solar and wind power generation in the world. And we can compare it, for example, with a nuclear power projections from the same report, and you can see that solar and wind will grow much faster than nuclear power and much faster than any other sector of the world power sector. And this we can see, for example, these scenarios produced by different experts from oil and gas companies, for example, like Total and BP, of research companies like Bloomberg, New Energy Finance, and DNV-GL. And all these scenarios show us that solar and wind will grow very quickly and become the main producers of electricity in the future. Well, but if we look at the oil consumption scenarios, we'll see the high degree of uncertainty, and so I can say that the future energy development is very uncertain. But if we consider net zero emissions scenario according to the country pledges to reach carbon climate neutrality, the oil consumption should be declined very quickly. If we look at the structure of the oil consumption in the world, we'll see that the transportation is the main sector of the oil consumption. And the development of the road transport, of the electric vehicles is the degree, the tempo of this of the development of the road transport is very important for the future of the for the future of the oil consumption. And we'll see last year, for example, that the sales of electric vehicles in the world and the main markets like Europe and China sales grow very quickly. And my last slide about the very interesting, very popular topic about the hydrogen economy. On this sector, there is also we'll see high degree of uncertainty about the future development. And here we see the graph from the International Energy Agency report about with some projections with one scenario of the future development of the hydrogen consumption. Well, this is actually that's all. Thank you for your attention.
Thank you so much.
Sorry, any questions right on the spot to the speaker, or we will then move on? No questions? Okay. Then I will probably give the floor to Valery Luzon and Alyona Sviridenko, who would be talking about climate action, which makes economic sense. I can imagine under the climate limitation conditions, right? So, are you here? Can you start?
Yes. Yes. Thank you.
All right. You're very welcome.
So, can you see the presentation?
Not yet. Now it is. Yes. It's on the screen, so you can go on.
Great. So good afternoon, dear colleagues and experts.
Good afternoon. It's nice to see and to hear you today.
And for today, we have prepared the presentation. You can see our theme on the slide. Climate actions make economic sense. And firstly, I would like to start with a small introduction. So, as you know, each of us wants to achieve better lives for ourselves and future generations. Governments want to secure economic growth, improve living standards, create more jobs, and reduce the poverty. And businesses want to expand and become more profitable. And today, we also know that the world must deal with one of the greatest challenges of 21st century, climate change. And here the question arises. So, is it possible to tackle long-term climate change while also now promoting economic growth and development? Or must we choose between our future climate security and our current living standards? So some people would argue that climate actions involve additional costs and thus reduce profits and overall companies' values, and it's impossible to make any change. But by investing in the fight against climate change now, we can achieve sustainable development in the future. And now we would like to prove this statement by examining whether it is possible to achieve lasting economic growth while also tackling the risks of climate change. We believe that countries at all levels of income now have the opportunity to build lasting economic growth. at the same time as reducing the immense risks of climate change. This is made possible by structural and technological changes unfolding in the global economy. And the capital for the necessary investment is available, and basically the potential for innovation is vast. And what is needed now is strong political leadership and credible, consistent policies. Now let's analyze some figures. So in 2021, global energy transition investment totaled $755 billion, beating the previous year by 27%. This figure includes investment in different projects. You can see them in the slide. And what is interesting that the Asia-Pacific region attracted the most investment at $378 billion and recorded the highest growth at 38%. And you can see this on the slide. The red line shows the Asia-Pacific region and its contribution. And now I give the floor to my colleague, Alona.
Thank you, Valeria. Now I'm going to tell you about interconnection between economic segments and climate actions. So let's see some figures also. It is known that the global economy will grow by more than half, and around 90 trillion US dollars is likely to be invested in infrastructure in the world's urban land use and energy systems. These are the key economic sectors where climate-smart investments can achieve multiple real-world benefits. So, as for examples, let's consider the energy sector. So, by renewable energy and energy efficiency policies, we can achieve energy security, fuel cost savings, create more job places, less air pollution, and therefore improve our health. As for the cities, implementing solutions like smarter urban planning, better public transport, and efficient buildings, we can reduce emissions in the long term and also help build more efficient, competitive, and livable cities. And when it comes to land usage segment, it's possible to provide land restoration policy. So, for example, restoring just 12% of the world's degraded land could feed 200 million people by 2030. And these cascading benefits of climate action appear in many other policy areas. But at the same time, there is a risk that there are many costs associated with the high carbon-related systems and sectors. Globally, the fossil fuel subsidies reached 5.9 trillion US dollars in 2021. It's a huge number. And the solution is that we need to shift our economy onto sustainable climate compatible path. It requires higher upfront investments, but it will be much cheaper in the long term. And international financing mechanisms, their names you can see on the slide, as well as technology sharing institutions are available to support this process to sustainable climate compatible paths. And finally, cooperation across sectors and regions is needed to fully realize the benefits of climate compatible policies. The World Economic Forum's Global Risks Report by 2021 identified climate action failure as the most impactful and second most likely long-term risk facing the world in a year when populations continue to struggle mitigating the impact of the COVID-19 pandemic. And the benefits that flow from investments in climate actions dramatically outweigh any upfront costs. So let's us seize our opportunity to shift the economy onto a climate-compatible path, invest wisely, and realize the benefits of climate action. So, as here you can see our references and also our contacts. Thank you all for your attention.
If you have any questions, we are ready to answer them.
Any questions for the speakers? No? From the expert side? Still not, probably at the end. Okay, let's then move on. Let's talk about climate change and adaptation of business to new climate conditions. We have quite a lot of presenters here, by the way. Арина Разникова, Елизавета Петрова, Ульяна Бучатская, Галина Федорко, Валентина Петрова, Елизавета Крылова. Are you all together attending the meeting? Are you here?
Yes, we are here. I guess
So then the floor is
we will,
yours.
I guess we will discuss one topic, but we are separate from each other.
Okay.
So we can start. Give me a second.
Oops.
Yes. So good
Yeah.
afternoon. Yes. Good afternoon, everyone. We are happy to see you here. My name is Petrova Elizaveta, and together with Arina Razinkova, we will present you the topic about permafrost thaw and firms' protective technologies against this problem. So, talking about it, for Russia, where permafrost occupies more than 60% of the country's area, the problem of weakening it is particularly, it's very relevant problem. And the greatest damage though of permafrost causes for industrial enterprises. So in Russian permafrost zone, a huge number of mining enterprises are located, whose activities are already under threat today. Every year, about 35,000 accidents are detected on oil and gas pipelines, and 21% of them are caused by mechanical damages, which in their turn are connected with soil deformation. Over the past 20 years, the number of such emergencies in the permafrost zone has increased incredibly. And at the end of the last year, Russian economy losses alone from the permafrost thaw were estimated at between 50 and 150 billion rubles a year. And these numbers are expected to continue their increase in the future. So this is especially significant for the country's oil, gas, and mining enterprises, and a huge part of which is located in the permafrost zone. So 15% of Russia's oil and 80% of gas operations are concentrated there. So one of the most representative examples of the influence of permafrost thaw is Norilsk oil spill on May 29, 2020, a fuel storage tank at Norilsk Taymyr Energy's terminal power plant number 3 failed, and it flooded local rivers with up to 20,000 tons of oil products, and they got into the soil and water. So the accident was described as the second largest oil spill in modern Russian history after the 1994 Komi pipeline spill, where about 400,000 tons of crude oil were released to the environment between August and January. It was estimated the immediate cost of emergency relief activities would be 10 billion rubles with a total cleanup cost of 100 billion rubles, which would take 5 to 10 years. So it's really terrible disaster, not only for the nature, but for the Russian economy, as the costs are very high. And one of the main causes of this disaster is unstable ground due to the melting of the permafrost. This problem is quite typical for the Arctic zone in the context of global climate change. So if diesel fuel is so harmful for the environment, we definitely need to replace it with something else, with other energy sources. So now diesel fuel is the basis of the industry in the Arctic. Diesel fuel is used primarily in transport, and it is less whimsical and costly. energy source, and with it, it's easier to generate electrical energy in remote areas such as Siberia, Yakutia, and others. So renewable energy can become an alternative to the diesel fuel. Already now in the Russian Arctic, there are successful examples of the use of wind and solar stations. For example, a wind farm was recently launched in Tixi together with the collaboration with Japan. So this wind farm combines existing generating facilities with wind turbine generators and a control and coordination system of renewable energy using diesel generators and storage batteries. So returning to the Norilsk region has one of the highest potentials for the development of wind energy. Wind farms can produce electricity, which can be also used to heat supply, which is also very important for this region. But wind electrostations are quite unstable due to the dependence on the weather and other factors. But lithium-ion batteries and hydrogen from wind power can support stable electricity generation. Now I pass the floor to Arina.
Thank you, Elizaveta. And how can we prevent permafrost thaw? So to protect infrastructure facilities from permafrost melting, thermal stabilization technologies are used, primarily seasonal cooling devices that maintain the ground in a frozen state. Such refrigerators, I can say, work on the basis of such systems, which extract the heat from the soil and transfer to environment, thereby cooling the land. These devices can reach sizes of several kilometers, and they are quite expensive, both in construction and in operation. In addition, other ways to ensure the safety of oil and gas pipelines are being developed. For example, Novatek uses gravity platforms for its liquefied natural gas transportation lines. The next slide, please. But globally, all these measures don't solve the problem of permafrost and the consequences of this process. The fact is that all new infrastructure is being built taking into account existing forecast of climate change, but any anomalies and sudden temperature fluctuations will ruin all expectations and lead to the same consequences as in Norilsk. In addition, investment in heat stabilizing installations and a complete reconstruction of the existing infrastructure will lead to a huge cost and multiple increase in costs of all northern projects. But the main way to slow down the melting of permafrost and global warming in general is considered to be limiting greenhouse gas emissions, of course, and commitments to reduce the amount of carbon dioxide in the atmosphere were secured first by Kyoto Protocol and then by the Paris Agreement, which Russia ratified. And their goal, as you know, I suppose, is to slow down the growth of the average temperature in the world to 1.5 or 2 degrees, because it's now not possible to completely stop warming. To accomplish this task, it is proposed the establishment of a carbon tax and recycling fees, the transition to energy-saving technologies and alternative energy sources, and of course, limiting deforestation. In September in 2019, Vladimir Putin ratified the Paris Accord 4 years after its creation, and this agreement means to Russia must commit itself to reducing carbon dioxide emissions to 70% of the level which was in 1990. But how does it impact? On businesses? First phase is carbon dioxide emissions reporting is mandatory for entities with more than 150,000 tons of emissions annually, and the government is to monitor, collect and publish data on emissions by sector and companies. And second phase is carbon dioxide quotas and targets are imposed on regulated entities. Verified emission reduction investment projects are supported by the government, and exceeding emissions quotas is the subject to penalties. However, the plan has been criticized for its lack of clear mechanisms, and many of the initial plans were watered down after pressure from industrial groups. That's all that we wanted to say about this topic. Thank you for your attention. We are waiting for your questions if you have.
All right, thank you very much. Any questions from the audience? No. All right, I pay attention to the very nice, well, like watered down. I like it. Actually, that means that we still don't have any particular plans how to regulate emissions, but we are kind of making the first move in Sakhalin. Do you know anything about that? Have you looked through the documents? No?
Actually,
Yes.
no.
Okay, some of them are already published. At least the law was published quite recently. It was adopted on March 6th. It has the number, I guess, 34, and it's about the regional experiment for limiting greenhouse gas emissions at regional level. I would suggest that you kind of look it through, and then maybe you'll a little bit change your attitude, but still it's a lot of unclear things even in that particular document. So we are kind of hiding behind, I would say, everybody else, and this, I guess, a little bit dangerous, but not only this, of course. Anyway, thank you very much. Anybody who would be talking on the same topic after you or together with you?
Yes,
No?
we will talk
Yes,
about
please.
another topic.
So you then please step in. The floor is yours. All right. It's working.
Yes. So is it working? Yes.
Yes, it is.
So hello, everyone. Today, me and my colleague Ulyana are going to tell you about how will climate change affect most sectors of the Russian economy. And I would like to start with the definition of climate change. So briefly, climate change is characterized by increasing changes in climate indicators over a long period of time, including precipitation, temperature, and wind patterns. So in Russia, temperature above the climatic norm were observed almost throughout the country, except for Chukotka. I'm sorry. So in our research, we would like to focus more on changes in temperature and how these changes affect sectors of the Russian economy. Moving forward, let's talk about agricultural industry. So as you can see, traditionally, the agrarian south is waiting for a much drier summer, and some scientists believe that the wheat yield in the Krasnodar territory may decrease by 25% compared to the current level. But fortunately, this challenge can be solved by introduction of drought-resistant crops and the development of irrigation that will smooth out this effect. So moreover, shifts in global weather conditions will lead to regular flooding of the southwestern Black Earth regions of Russia, and that will affect one of the most important items of Russian exports, grain, which is almost 80% is wheat. And due to the poor climatic situation, yields will decrease, and frankly speaking, similar problems already arise quite frequently. And what is more, scientists warn that the cultivation of hydrocarbon-rich land will only accelerate global warming, forming a vicious circle. So now I'm giving the floor to Ulyana.
So let's move on the question of how will global temperature rise affect forests. There are three crucial problems. Firstly, to increase the fire danger, the scale of forest fires and the damage caused by them. Warming itself increases the duration of the period when fires are most likely, up to the point that in the south of the country it becomes year-round. Secondly, global temperature rise creates favorable conditions for many pests and pathogens of forest disease, while the ability of trees to resist them is reduced as a result of droughts or abnormal heat. Thirdly, an increase in temperature leads to a significant change in forest ecosystem and landscapes. Taiga forests will retreat to the north and into the mountains, giving way to ecosystem of the temperate zone. Droughts in southern forest zone will lead to the drying up of forests. The renewal of trees will become less successful. Forests will turn into steppes in places. And next, Galina will tell you about the financial sector.
So now let's talk about the financial sector. And it is assumed that many central banks have recognized the importance of increasing financial risks due to climate change. So these risks include potential losses on loans from banks as a result of some interruptions in work caused by storms, droughts, forest fires, and other extreme events. There are also risks of a transition to a low-carbon economy. For example, there could be unforeseen losses in the value of assets, or companies depend on fossil fuels. Furthermore, some central banks also recognize that climate change is becoming an increasingly pressing issue for monetary policy, and climate-related financial risks can affect the economy through increased credit spreads, more cautious savings, and in extreme cases, it could also cause a financial crisis. There may also be direct consequences, for instance, infrastructure damage, agricultural losses, and commodity price spikes caused by droughts, floods, and hurricanes. In addition, I would like to say that weather disasters abroad can affect exports, imports, and disrupt supply chains. And now, Uliana are going to tell you about the tourism.
Yes, so climate change has had a minor impact on the tourism sector, but in 5-10 years, this impact may become considerable. And in 50 or 100 years, irreversible changes are expected both in landscapes and in the loss of some attractions, especially in northern latitudes. For example, employees from the Russian Wave company noted that in 2020, there was a little amount of snow in the Caucasus. It was rainy in January, and the company has to cancel snowmobile rides as the winter season was almost gone. And on Lake Baikal too, due to warming, the ice has dimmed and lost its charm. And the last, energy sector. So due to the increase in winter air temperature, there is a tendency to shorten the heating period. This will lead to a change in the structure of energy consumption. Energy costs for heating premises will decrease. At the same time, changes in the warm season are more negative, since an increase in air temperature and possible shortage of precipitation can lead to fail in water resources, which are necessary for cooling thermal power plants and nuclear power plants. Also, a growing number of days with an air temperature of plus 25 degrees or more will negatively affect the transmission of energy because with the rise in air temperature, the transmitted power along the power line decreases and electricity losses also rising. In addition, by 2030 to 2039, the electricity consumption for air conditioning will be greater as the air temperature will become much higher. As a result, a significant increase in heat consumption and the air conditioning and the reduction in electricity consumption for heating buildings is expected. So that's all we wanted to tell you, and thank you for your attention. If you have any questions, we will be happy to answer them.
Thank you.
Thank you.
Any questions again? No. So I guess we have the final pair of representatives for this particular topic.
Mikhail, I have a question.
Yes, please.
Yes, I have a question about the agriculture. So there is a lot of projection that we will have increase in agriculture productivity for Russia because of this increase in growing season and CO2 fertilization effect. So can you say something about it?
Yeah, so I saw the information that climate change can both have negative and positive effects on agriculture industry. But in this presentation, I wanted to focus on particularly on disadvantages of climate change.
But probably we have more advantages than disadvantages when we talk about agriculture in Russia. We have some risks, of course, but we have more advantages. You have
Well, the question would be then talking about advantages. Are they going to come or appear in the same very regions where we have already advanced agricultural production, or in other regions? Because if you are talking about some other regions, for instance, like Altai or whatever, then these advantages would come at a rather huge cost. No?
Yes, it costs a lot of money, like adapt to that climate changes and to like create some equipments in order to support our production in
First of all, we have to
agriculture
remove
industry.
the whole production a little bit up to the north, right? In order to catch up with this new climate conditions, which are advantages for the agricultural culture growth, right? And whereas when we're talking about the particular regions where we have more or less developed agricultural productions at the moment, then those regions will be mostly, I would say, degraded by the climate change because of droughts and stuff like that. Alexander, would you agree that the advantage?
No, I cannot completely agree with you. I understand that. I know that we need to adapt to positive consequences of climate change, but when we talk about changes, we shouldn't talk only about drought and temperature increase. We also should about CO2 fertilization effect, and it's very important for plants. They do not need so much water, for instance, because of this CO2 increase. So you just also should look at this side. That's
yeah.
There's not only one side. There's both sides of climate change.
Yes, maybe in the future we'll look at
what
some
about
advantages.
soil degradation in this case? I saw at least like 3 big volumes of the ongoing research about the condition of the soil in Russia, where the main topic and the main trend is degradation.
Yes, soil, but most of them they degrade not because of climate change. It's because of the anthropogenic impact on this. So it's
okay.
But it's
interesting.
That's true. It's mostly degraded. Yeah, degraded. Yeah.
Yeah, but Alexandra, I know what you're talking about this fertilization effect. So yes, I understood you.
Okay.
Okay, thank you. Okay, shall we continue and then with the same topic?
Yes, we are ready. We can
yes,
start.
Please.
Can you see my presentation? Yes.
It looks good.
Okay. Good afternoon. I and my colleague Elizaveta prepared a report about climate change in Siberia, and today we want to share this information with you. Siberia is a potential area of economic development in the real time, and climate change has caused temperatures in Siberia to become milder with both warmer winters and cooler summers. This has a variety of problematic side effects. Firstly, warmer temperature mean melting ice and permafrost, but also increased snow. The extreme cold of Siberia winters prevent snowfall, but a minor increase in temperature prolongs the snow part of the season. All of this leads to increased humidity and flooding, which makes farming much more challenging. Furthermore, the temperature has also become much more volatile, making it difficult to predict then the most optimal farming time and how much to stockpile.
Scientists have concluded that the abnormal heat was most likely affected by human activity. Climate change increased the likelihood of a prolonged period of heat in the first half of 2020 by about 600 times. Without it, the temperature in Siberia would be at least 2 degrees cooler. Forecast models have shown that in the best case scenario, 2050, the average temperature in Siberia will be 2.5 degrees higher than in 1900, but it may also be 7 degrees higher. The increase in average annual temperature will make the climate of Siberia much milder and livable for humans by 2080.
If greenhouse gas emissions are not stopped, January temperature in Siberia will rise by 9 degrees and precipitation will increase. As a result, the climate will become milder and the permafrost area will be reduced by 25% by 2080. It is expected that by 2080, due to rising temperatures, the climate in Siberia will become suitable for human life and agriculture, even in the Arctic zone of the region. Climate change in Siberia can flow two scenarios depending on the development of the situation with greenhouse gas emissions. If the man-made impact on the atmosphere becomes minimized, then the changes will be less pronounced. Then, according to scientists, the area of Siberia, which is absolutely uninhabitable, will be reduced by half. At the same time, the population density in the Asian part of Russia will be able to grow 5 times. If greenhouse gas emissions remain the same or increase, the climate and conditions in Siberia will change much faster. As a result, up to a third of the territory of Siberia will even acquire the features of a climate comfortable for human life.
Russian scientists have identified a link between air temperature and the volume of river runoff. They found that an increase in air temperature accelerates the thawing of frozen soils, which leads to an increase in the water level in the northern rivers. At the same time, at elevated air temperature, evaporation in the pool increases, which leads to a decrease in the intake of moisture into reservoirs. Ice melting threatens coastal and island states to a great extent, but not Siberia. It is believed that Siberia will be a safe place as it located in the depths of the continent and is raised from 300 to 400 meters above sea level. The entire vast territory of Siberia is subject to such a phenomenon as permafrost. The Siberian permafrost melts in many problematic side effects on its own, most of which stem from the frozen methane trapped within it. Methane is a greenhouse gas estimated to be more than 20 times worse than CO2. And as the permafrost melts is being released into the atmosphere, this could have major ramifications for our climate change models, especially given that it's difficult to estimate exactly how much methane is being released.
According to climatologists, the amount of precipitation is changing in Siberia. If climate changes, the situation with fires will worsen and the forest will burn more and more often. A forest fire is always accompanied by emissions of gases and soot. If there are more of them, the carbon content in the atmosphere will increase and the greenhouse effects will increase. Widespread flooding, as the ice in Siberia melts villages and cities across the region are experiencing widespread flooding on an almost yearly basis. This causes death and serious damage to homes and infrastructure, the very infrastructure that the more remote villages now rely on to get their food. Climate change in Siberia also has implications for diseases. Flooding, for example, leads to overflow from water treatment systems and impure water. But more than that, as temperatures rise, diseases carry spread further north. However, is that deadly diseases like anthrax can stay available frozen in ice for a century or more, and we are now getting reports of outbreaks from diseases unfreezing.
Due to the warming of the climate in Siberia, agriculture territories will increase. In a changing climate, the duration of the growth season will increase, which opens up prospects for growing crops in the north of the agriculture zone of Siberia. Additional irrigation and more active use of mineral fertilizers will be required, without which farming here will become unstable.
The task of developing Siberia is a scientific and industrial center is critically important for achieving the strategic goals of Russia's economic development. Therefore, in the future, there is a need to form new growth centers in Siberia, territories of the future based on advanced technologies and preservation of the natural environment. According to scientists, the area of the territory of Siberia, which is absolutely uninhabitable, will be reduced by half, while the population density in the Asian part of Russia will be able to grow 5 times.
The effect of climate change on Siberia serves as a warning for other parts of the globe, and we need to be prepared for similar change to occur elsewhere. Also, the villages in Siberia haven't fallen apart. They also had an external infrastructure to fall back on, and they are not tied to the survival of this infrastructure they have little control over. As climate change affects more regions of the globe, people will have to require strategies in place if they want to survive. Thank you for your attention, and we are ready to answer questions if you have.
Thank you.
Thank you very much. Does that mean basically that you tend to see Siberia as like a new paradise on the earth due to climate change, or you still think that we will face a lot of troubles in that particular part of the world? I mean, first of all, the wetlands, which tends to increase because of the permafrost melting and many other things. What is your final conclusion? Whether Siberia is a promising land, or is it not?
I think that Siberia is a potential area of economy development, and our strategy is reorientation to the east, because China, our country needs to develop relationship with developing countries, for example, China, because China is a very developing country, and try to implement their strategy in our regions.
What kind of strategy? So if you think that we should turn to the east, then do you think we have anything to supply, to propose for the east market? What exactly it could be in this case? Natural gas? Forest? Human resources?
I think agriculture.
Agriculture.
Agriculture industry, yes.
In Siberia?
Yes.
Are you going to buy the first Siberian hectare of land to start agricultural production there? Are you considering this option? All right, you will think it over. Thank you very much, anyway, for your presentation.
Thank you.
Alexander, do you have any more particular questions about this?
Yeah, I just want to know the source for this increase of volatility of temperature that you showed on the second slide, probably. Actually, what I've seen, there is a decrease of volatility of temperature. because we have increase in temperature and we have the more intense increase in winter temperature and minimum air temperature, and so we have a decrease actually of this how to say variance of temperature, not increase, decrease. So what is the source of your data?
I mean that the temperature is going to become more stable over the year.
Yeah. Not that big changes between day and night, between winter and summer. We have a decrease, not increase. What I saw. Maybe you have some other sources. So what is your source?
I think that the temperature would be in a middle.
When you talk about volatility, that means that
volatility is it's amplitude.
The high and low is going to increase, right? Or it's going to shorten over the time.
Milder temperature.
The temperature is going to be milder, okay? And then the difference between winter and summer, night and day, is it going to be higher or lower?
Higher, I think.
All right. It goes lower, actually.
Okay, thank you very much. It was nice to see your opinion. Then we have two solo presentations left, and we will start with Anna Kitova. What is the right way to pronounce?
It's Kitova.
Kitova, sorry. Then the floor is yours, and you'll be talking about the carbon footprint reduction prospects at Novolipisk metal.
Yeah, Novolipisk.
Okay, interesting. Cool. We've been doing a lot of things at that plant over the years. It would be nice to come back. Okay.
Yeah, it would be nice to hear your questions also about this topic. So, well, I would like to test the switching of slides because I think I might have some problems with it as well.
It is. But
so
it's not a full screen.
It's not the full screen right now.
Well, now it is. So, okay.
And that's the second slide or the first one.
No, it's still the first. It's the
so
cover
it
slide.
Doesn't switch and right now?
Still the cover slide.
Well, then maybe
yes.
I would...
Now it's moving.
Yeah, now it works.
So, and
this is the first slide, basically. This is cover slide.
And right now, it's is it the second or the first one still?
Now it's the first. It's like a cover slide, right? It's like the name of the presentation.
Okay, so I would just switch them. Not
now it's all right.
Okay.
This is the first slide. All right, okay. Cool.
So first of all, thank you very much
Stop
for
doing things.
I'm sorry.
Okay, move on.
Thank you very much for the opportunity to speak out on such important and acute topics. I'm very glad to present you the my key findings of my research on carbon footprint reduction prospects at NLMK group. So has it switched? Okay. So to start off, why is it important and what are the main drivers for decarbonization efforts? So by 2060, Russia has pledged to become carbon neutral, as many of the world's countries. And iron and steel industry accounts for 9% of Russia's and the world's greenhouse emissions. So that industry is to be paid special attention to. Other important driver is that in Lipetsk, where 80% of NLMK's capacities are located, people are exposed to an increased risk of inflammatory diseases. So, for example, in 2019, 12,000 of the citizens of Lipetsk were diagnosed with bronchial asthma and the second, the most common inflammatory disease there is COPD. So given that these diseases are chronic and they are not easy to, they are not actually treated fully. That's quite significant. So other strong challenge comes from the European Union, where NLMK exports a big amount of its production. So in the European Union, a special cross-border adjustment mechanism will be implemented in the near 4 years, and the system will be the following. So the import production will be assessed, evaluated on the matter of carbon intensity, and it will and special taxation will be imposed on this production in accordance to the carbon prices in Europe. So the CBAM actually will drastically affect companies' European export. Challenge also comes from the market itself. So there is a growing demand in green steel. For example, Volvo car making group already requests its key steel supplier, CCSSAB, to provide it with 25,000 of green steel each year. So I think that all of the drivers have like a domino effect. So for example, CBAM, it will be imposed not only in Europe, but in other countries that have serious drives to decarbonize. So does it switch?
Yes,
so
yes.
in order to better realize what spheres of production need to improve, I put here a scheme. So basically, 57% of NLMK's emission comes from the stage of melting iron. So these are two interconnected processes of blast furnace, melting, and basic oxygen furnace. However, there is an alternative route of melting iron. It's by electric arc furnace, and there is a key difference between them because they use, first of all, they use different kind of feedstock. So for electric arc furnace, a feedstock is containing more iron ore in proportion, and also this route is twice less energy consuming. So as we realized that there is an alternative for blast furnace production, which is direct iron reduction, we can think that it would be widely implemented in steelmaking companies. So basically, direct iron reduction, it's the technology of producing feedstock for electric arc furnaces, and the principle of this technology is fundamentally different from blast furnace. So the pellets are directly reduced with natural gas or coal, and this process is 60% less carbon intensive than blast furnace process, and it's actually less energy consuming. So NLMK plans to set up HBI facility at cost of 250 billion rubles in 2028, and the effect will be 3%. I'm sorry. Okay, it will be 3% emission reduction. We can assess this project as it is stated in the investor presentation. So it is set to be implemented. So this project has obvious advantages. For example, it is with the HBI technology, it is possible to gradually convert to hydrogen-based steelmaking. So, for example, Midrix, which is the most popular technology provider, has several stages of improving the process, varying the fueling and electricity sources. Second advantage is high added value of HBI, which makes it profitable for export. However, there are some significant drawbacks of this technology. So the first one is that the cost of HBI production is slightly less than NLMK's finished steel production cost. So if a ton of HBI costs $207 per ton, NLMK's finished steel costs NLMK's finished steel costs $207 per ton, and HBI costs $200 per ton. Moving on to the next drawback, the pellets that are put in direct iron reduction furnace need to have 70 plus iron content, whereas the current pellets, the current NLMK's pellets contain only 65% of iron, which will result in additional expenses for fuel, namely natural gas. So, to draw the conclusion from this information, I would like to point out that despite of the obvious advantages of HBI process, still the drawbacks outweigh them. So, for example, the majority of American and European steelmaking companies have set an ambitious goal for 2030 to reduce their emissions by 30%. Actually, HBI facility at NLMK is one of the most ambitious project, and we can see that by 2028 it would reduce only 3% of companies' emissions. So the project may not meet the expectations of investors, and it may fail to provide low carbon steelmaking strategy. So there is another technology to reduce carbon emissions. It is carbon capture, utilization, and storage. The principle of this technology is the following. The CO2 emissions are captured at the plant, then they are transported by either pipelines or ships or trucks, and then they are either stored at the special facilities or utilized for other production. So, having analyzed foreign cases, I have drew out some conclusions. So, first of all, currently operate 19 facilities around the world. Only one of them is implemented at steelmaking plant in the United Arab Emirates. However, its capacity is quite low. So it captures only 2% of NLMK's current emissions rate level. And well, there are the US is the most developed countries in terms of CCUS implementation. So, for example, it has developed the infrastructure for transport for CO2 transportation. So it has the longest pipeline, which length is 8,000 kilometers, and additional 3 will be implemented in the near future. Having mentioned the utilization opportunity for CO2, there is one project of ArcelorMittal company. It aims at utilizing carbon for production of bioethanol, and to do this, it plans to set up a on-site plant which will be operating using the emissions of the company. So moving on to Russian realities, I can say that there is an outstanding research which has revealed that Russia's geological potential to store CO2 is enormous. So basically, nowadays Russia can store all of its quantities of CO2 emitted. So the research by Vegan Consulting also proposes it models Volga-Ural cluster of CO2. This is the cluster of emitting and consuming enterprises, which will be cooperating to use CO2 for oil recovery purposes. So enhanced oil recovery is a special process that allows to increase the output of oil almost twice as without it. So the starting capacity of the cluster will be about 40 million ton of CO2 per year. And to interconnect the enterprises, there will be a transportation system by pipelines, which length will be 1,300 kilometers. A pipeline is actually the cheapest way of transporting CO2. However, Lipetsk NLMK's Lipetsk site is quite remoted from the cluster, the plant cluster, so that would complicate the transportation of CO2 to oil province. That's why I've dive into the opportunities of utilization CO2 for NLMK, and I figured that urea production is the largest scale chemical CO2 application. So leading urea producers need more than 3 million tons of CO2 per year, which is basically more than 8% of NLMK's emissions. And break-even cost of urea production is 2 times less than steel production cost at NLMK. So having said all of this, I propose to consider setting up a urea plant at Lipetsk site at NLMK. So speaking about the conditions that stimulate CCUS projects, it's needed to be mentioned that the majority of CCUS projects are supported by the government. However, there are some drawbacks in the regulation and in the policy. The major drawback is that if there is institutional separation of carbon capture, utilization and storage projects, that complicates the approval process. The obtaining of license for these projects. For example, in China, basically CCUS has include many aspects in it, like electricity, oil, soil, water, and other resources are included in this process. So in China, all of these aspects are controlled by different authorities. So what we need to do is to make comprehensive and specified CCUS regulation in order for it to contain all of the spheres related to CCUS. Among the successful governmental policy, I can name American tax credit 45Q. That stimulated 8 new projects since 2019. So it works. By 2026, it will cover the break-even cost of CCUS projects. So that's the very it's a very successful incentive, and that stimulate the emerging CCUS projects. I would like to make a conclusion from this slide. So first of all, carbon capture, utilization, and storage is considered to be the most feasible decarbonization technology in steelmaking in the near 50 years. Actually, there is no a lot of data nowadays of these projects. However, specialists say that the main issue in this technology is to find the application for CO2 rather than to install the facility. That is why once we manage to find feasible and economically viable ways of utilizing CO2, it will be easier for considering these projects. So the technology basically provides the opportunity to capitalize CO2 emissions, and also it, as I have already mentioned, it is the scale of this facility is not impeding its the scale of the facility is not the main issue. Going back to Russian current situation, I can say that the most feasible way to reduce carbon footprint right now is to increase scrap input in electric arc furnaces. So, as we already know, electric arc furnaces are twice less carbon intensive than blast furnace route. So, however, there are some serious issues that impede these initiatives. So, actually, in Russia, right now, it is possible to collect for metallurgy around 30 million tons per year of scrap. Furthermore, scrap dumps present serious danger to closed regions, and because they emit dust, metal oxides, oil products, and that way they pollute soil, water, and atmosphere. Scrap collection currently depends on the feedstock conjuncture. So it depends mainly on the cost of iron ore, because it is the alternative of scrap, and it also depends on the transportation cost. So if the scrap dump or abandoned plant is situated far from the site of the company, it is not profitable to transport it. Scrap production is scrap collection and realization is strictly controlled by the government, because it's the essential industry of for export. And I think I propose that the company will increase scrap collection and processing, because there are a lot of because scrap collection is not used to its limit right now, and it should be implemented regardless of the costs, because it will really make change in companies' emissions. So now I would like to move on to my key findings. So to start with, in 6 years, an on-case HBI facility will reduce only 3% of companies' CO2 emissions. The required investment is 3.5 times more than 2020 investment budget. Also, moving on to CCUS project, depending on CO2 transportation cost, NNK can either join Volga-Ural cluster for enhancing oil recovery, or set up its own CO2 utilization plant in Lipetsk. So one of the CO2 utilization options is urea production. And the final finding is that there is a lot of scrap in Russia that is not collected and reused, and it makes damage to the environment. So scrap input in electric arc furnaces should be increased significantly. That is all. Thank you very much for your attention. I would be willing to answer your questions. Okay, so if there are no questions, I would stop the demonstration.
Thank you very much. It was really interesting. Thanks.
Hello. Any questions to the speaker? No? Or yes?
No.
Then finally, I guess we have the final presentation for today's session by MGIMO. It's going to be about the influence of.
Sorry, MGIMO is not participating.
No, she's not here.
No. Last night I received a message. I thought you knew.
All right. So basically, we have done, right?
Well, looks like that.
Okay. So, guys, any thoughts about the topic to discuss, or maybe to raise some more issues that have to be discussed? No? No, in this case, thank you very much. I guess we are right in time. It was good to see and to hear. Thank you again. Thank you once again for the organizers, for their courage, for their ongoing attempts to make the world better. Thank you very much.
Thank you.
Bye-bye.
Thank you very much.
Thank you very much
Thanks a lot.
to the experts.
That was
Bye.
great to listen to you. Thanks. Bye.